Mr. Hill, and welcome to the continuation of Laws of Exponents. Today is going to be Power of Powers. So let's get to it. My motto of the day is still, if in doubt, expand it out. Because in Laws of Exponents, this is pretty much the only motto you need. If you don't know what you're doing, if in doubt, expand it out. Now let's read the definition. A power on the inside and a power on the outside of these parentheses, like you see here, must be multiplied together, which is exactly what we see here as well. A to the nth power, all raised to the nth power, is going to give me a to the m times n power. Okay, let's do this quick example. We have 2 cubed, all raised to the second power. If we follow our rule, we're going to end up getting 2 to the 3 times 2. And we know what 3 times 2 is. 3 times 2 gives me 6, so overall this will be 2 to the 6th power. Now, you know me, I need to actually know what's going on, so we're going to do that next. So let's see what's actually going on. As you can see, if in doubt, expand it out. Of course, that's exactly what we're going to do. So I have written down the previous problem, so let's get down to it. We know that anything squared is going to be that number, or that base, multiplied by itself twice. So I can rewrite this as 2 to the 3rd times 2 to the 3rd. Now, it becomes a product of powers, which just means all I have to do now is add those exponents. So I can follow that rule and get 2 to the 6th power. But remember, I want to expand all of this out. So let's go back a couple of steps and let's go straight to here. 2 cubed times 2 cubed. I can still expand those out. I'll get 2 times 2 times 2. Here's that first 2 to the cubed power. Still multiplying. 2 times 2 times 2. Here's the second 2 to the 3rd power. Now, an exponent is a base being multiplied by a certain number of times. That number of times will be my exponent. So I see here 1, 2, 3, 4, 5, 6 times. So I still get 2 to the 6th power. Here's a problem involving a variable. Here I have x to the 4th, all raised to the 3rd power. So let's use our formula on this one. So I still keep the same base, multiply the exponent. So 4 times 3, and we know 4 times 3, that's 12. So I get x to the 12th power. That's by the formula, but if in doubt, expand it out. So let's do that. So I'm going to rewrite it here. Now that 3rd power tells me to multiply x to the 4th 3 times. So there's 1, there's 2, there's 3. Like I said in the previous example, this now becomes the product of powers, which means I can just add those powers together. So it'll be x, 4 plus 4 plus 4. And 4 plus 4 plus 4 gives us 12. And if you're still not convinced, I can separate every single one of those x to the 4th. So let's do that. So here's x to the 4th times x to the 4th times x to the 4th. So I get x, 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 all multiplied together. This is my first x to the 4th times x times x times x times x. There's my second x to the 4th power and then x times x times x times x. And there's my last x to the fourth power. Remember that an exponent tells me to multiply the base by a certain number of times. A certain number of times will be the number of the exponent. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we will still get x to the 12th power.